Hello, future RMTs. Welcome to our discussion. And our topic for today is all about enzymology. Okay, so this is like what I've said, this is the continuation of our clinical chemistry one. And part of this is about clinical enzymology. Okay, I hope that you still remember our discussion in proteins and amino acids as they are important in order for you to understand the chemical composition of our topic, which is about enzymes. All right, to start with, our learning outcomes are as follows. Number one is to recall the general properties, nomenclature, and significance of enzymes. Now, what is the purpose of the enzyme in the biological uh, mechanisms or biological reactions that occur in the human body, as well as, of course, for you to understand and analyze the laboratory results in relation to enzyme analysis. But disclaimer before I proceed, part of this discussion is all about the physiological functions of enzymes only. Okay? The discussion about laboratory analysis will be discussed in our laboratory subject. Okay, so let's proceed. Generally, no, the general properties of enzymes. You all know that enzymes are specific biologic proteins. Okay, they are specific biologic proteins. Enzymes are proteins that catalyzes biological reactions or biochemical reactions. Okay, and it's one of the most well-known function of our enzymes. They are the one that catalyzes biological reactions or biochemical reactions. Even though that they catalyzes biologic reactions, it is interesting to know that enzymes no do or catalyzes biological reactions without altering the equilibrium point of the reaction or being consumed or changed in the composition. Okay, remember, no? Remember that enzymes may catalyze many specific physiologic reactions. Okay, and these reactions are facilitated by enzyme structure and several factors. All right, if we are going to discuss again the structure of enzymes, no, it is composed of a protein. This is a protein, a sequence of amino acids, no, and remember, no, since this is a protein, no, meron siyang property similar to that of a being a protein. Remember also that our enzymes is found in, okay, so I will use that, found in all body tissues following cellular injury. No, the reason why enzymes are increased is because of there is a cellular damage or cellular injury. Okay, if not cellular injury, it is followed by degradation. Okay, so like what I've said, enzyme is a amino acid, a protein which is comprising of specific amino acid sequence. Now, it is important to know that our enzymes exhibits different forms. In fact, we have what we call isoenzymes. Okay, now what do we mean by isoenzymes? When we said isoenzymes, these are generally used to distinguish such enzymes. Okay. However, the International Union for Biochemistry nor suggests that this term should be a form of generic origin. Okay. Remember also, no, remember also, before I forgot, no, remember that enzymes uh, may be different from each other. No, may be different from each other. And it is based on certain criteria. Number one, because of its physical properties. Number two, what you call this? Solubility. Number three, resistant to inactivation. And number four, isoelectric mobility. Okay, so going back, again, when we said isoenzymes, no, isoenzymes is used to differentiate, no, our enzymes, no. Now, We also have what we call isoform. And when we said isoform, no, it is an enzyme that is subjected to post-translational modifications. Remember that isoenzymes and isoforms, no, contribute to the heterogeneity in the properties of our enzyme. Aside from that, we also have what we call cofactors. And what does it mean? When we said cofactors, it means that uh, these are non-protein molecule. Non-protein molecule, no, from the word itself, non-protein molecule. But these are important. No? These are important in the enzymatic reactions. Okay? These are important for enzymatic reactions or what we call enzymatic activity. And cofactors, no, we have what we call activators. From the word itself, activators, it activates a non-protein compound that activates our enzyme activity. Usually, when we said activators, they are non or they are inorganic compounds. Okay? They are inorganic factors, they are inorganic substances. Best example of which is the magnesium chloride, magnesium ion rather. No? Magnesium ion and chloride ion. No? These are inorganic elements, inorganic compounds, inorganic cofactors that serves as the activator for enzymatic activity. Aside from activator, we also have what we call coenzymes. And what is the difference between cofactor, activator, and coenzymes? Basically, cofactors, activators. I'm sorry. Basically, activators are non or inorganic compounds. Okay. When we said coenzymes are organic compounds. Okay. So let's make it clear. When we said no activators or activator, these are inorganic in nature. And when we said coenzyme, these are organic compounds. Again, to give you an overview or example, we have here your chloride ion and we have here your magnesium ion. By the way, uh, instead of saying chloride, since this is an ions, no, it will be better to say instead of saying chloride ion, no, it is acceptable to say chloride. Okay. Now, when we said coenzyme, these are what we call organic compounds. Best of example of which is our NAD, and we have what we call the pyridoxal phosphate. No, PYR, pyridoxal. Okay, pyridoxal phosphate. Now remember, guys, no, remember that NAD, no, our NAD participates in various chemical reactions. In fact, no, in fact, it is involved in transferring, okay, of hydrogen. If you still remember your biological cycles in biochemistry, di ba? You encountered NAD. All right. To give you a more detailed discussion on that, no, remember that, for example, the reaction, okay, this is the reduced form. Why reduced form? Because no, it gains uh, hydrogen plus NAD plus no, and take note that this is a reversible uh, reaction. Okay, no, this is a reversible reaction. How? Depending on the circumstances. Remember that NAD plus may accept hydrogen atom like this. No? May accept hydrogen atom. And take note that NADH may donate one hydrogen atom. Okay? Uh, Take note also that when NAD is involved as part of the enzyme reaction, it is usually in solution and not, no, okay, usually in solution, okay, usually in solution, not tightly bound as part of enzyme molecule itself. Okay. Again, cofactors, no, are essential to activate, to facilitate enzymatic activity. These are your activators and your coenzymes. The IUB, or International Union of Biochemistry, no, assigns a systematic way of naming our enzymes for the classification and nomenclature of our enzymes. In fact, the IUB, or International Union of Biochemistry, provided 6 classes of our enzymes, namely as the oxidoreductases, transferases, hydrolases, lysases, isomerases, and ligases. If we're going to discuss oxidoreductases, it's basically an enzyme that facilitates or that is involved in what we call oxidation reduction or oxidation reduction reaction. No? Oxidation reduction reaction, or most commonly known as the word of redox. It's easy to remember because oxidoreductases. Again, these are our enzymes that facilitates oxidative and reductive reactions. Okay? And to give you a thorough discussion, remember, in biological system, it is usually means addition of hydrogen to a double bond. No? Addition of hydrogen, if you are going to recall your basic organic chemistry class, no? Bonding, i-break, once the double bond is na break, no? Once the double bond between the carbon-carbon ay na break, it will leave a carbon, no, with missing electrons. Therefore, this missed electron, so that the carbon will be on the octet, no, there will be uh, addition of hydrogen. Okay, there will be a addition of hydrogen. Remember that the older name of our oxidoreductase is dehydrogenase. That's the older name. No? That's the ancient name. Yun yung luma. Okay? Hydrolase. Dehydrogenase rather. Dehydrogenase. That's why if you are going to recall or if you are going to take note of examples of enzymes under oxidoreductases, examples of which is the lactate dehydrogenase, the glucose 6-phosphate dehydrogenase, and the glutamate dehydrogenase, LGG. No? Lactate dehydrogenase, glucose 6-phosphate dehydrogenase, and glutamate dehydrogenase. Now, if we are going to discuss the functions of these enzymes, it's basically involved in what we call redox reaction. Okay? Next in line is we have the transferases. Okay? From the word itself, transferases, it catalyzes an enzyme that catalyzes the transfer of one group to another group. No? Transfer of a group other than hydrogen from one substrate to another. Okay? Then there is a transfer of intact group of atoms from one molecule to another. Okay? There is a transfer from the word itself, transferases. Remember, remember, the group is a functional group. No? Yung group na minumove, yung group na tinatransfer is yung functional group. Example of which is your amine. Okay? Example of which is a amine. Okay? Now, a phosphate group from ATP or adenosine triphosphate is transferred to the nitrogen atom to creatinine to adenine diphosphate. So it's basically, for our transferases, it's basically ATP plus your creatine, will give you ADP plus creatine phosphate. So there is a transfer of what we call a functional group. Aside from amine, before I forget, aside from amine, the other group that is being transferred by transferases enzyme is no other than our phosphate entity. No? Yung mga phosphate natin. Yan, tinatransfer din po yan ni transferases. Okay? Best example of transferase enzyme is no other than your AST and ALT, right? Your aspartate aminotransferase from the word amino. Ano yung tinatransfer niya? Yung amino group, yung amine group, because amine is an amino group. Okay? Organic chemistry. Okay? Alanine aminotransferase, it's basically the same. No? Amino group din ang tinatransfer from one group to another. We also have your creatine kinase, gamma glutamine transferase, your glutathione S transferase, glycogen phosphorylase, and pyruvate kinase. Okay? Next in line is we have the hydrolases. Ano naman yung ginagawa ni hydrolases? Hydrolases is an enzyme that catalyzes hydrolysis of various bonds. Hydrolysis. Hydrolysis of various bonds. Or, to make it more detailed, hydrolysis is an enzyme, take note of this. Hydrolysis is an enzyme that is involved in the splitting of molecules. No? Splitting of molecules. Review. Oxidation, oxidative or oxidoreductases, for redox. Transferases transferring of amino group and or phosphate group. And when we said hydrolysis, enzyme that catalyzes hydrolysis. And to be exact, splitting of molecules. Take note, splitting of molecules. Okay? Now, this splitting of molecules with water is part of the reaction process. Okay? There are a lot of clinically significant hydrolyses. Okay? Meron tayong mga clinically significant hydrolyses. Example of which is your alkaline phosphatase, your acid phosphatase, amylase. Amylase is a best example of what we call hydrolysis. No? Remember, sulat po natin, I hope that you are still with me. Remember, I need black screen. Yan. Usapin natin, hydrolase, hydrolase. The example of which is your amylase. Anong ginagawa ni amylase? Amylase is important or involved in the cleavage of carbon-oxygen bonds. Okay? Amylase is important in the breaking or what we call or hydrolysis of carbon-oxygen bond. Now, this is an ester bond. Diba? which is found saan? Sa starch. Huh? Which is found in starch. Remember that the what you call this uh, hydrolytic enzyme lipase breaks down naman triglycerides. Si lipase, ano naman, yung triglycerides, di ba? If you still remember in our clinical chemistry 1, it breaks triglycerides to glycerol and free fatty acids. Kasi ano yung sabi natin? Triglycerides is formed by fatty acids. Actually, three fatty acids and a glycerol. Yung iyong alcohol. So yung triglycerides, so that it will be broken down into smaller or simple part, si lipase, binibreak yung ating ester linkage. Can you follow? I'd hope so. Huh? So that is what we call hydrolysis. And we also have the fourth class is lysase. Now, let me just change the color of my ink. Ano naman yung lysase? Si lysase naman cleave the carbon-carbon bond, the carbon-oxygen bond, and the carbon-nitrogen bond. Okay, I repeat, si lysase, ano po yung binabreak niya? No? Carbon-carbon bond, carbon-oxygen bond, and carbon-nitrogen bond. Okay? And remember, if hydrolysis requires water to split, take note that lysase did not require. No? As the name implies, lysase, it splits molecules. No? As the name implies, lysase, it split molecules. Again, what type of molecules? Carbon, carbon bonds, carbon, oxygen bond, and carbon, nitrogen bond, or even other bonds are possible. Okay? Take note that the reaction are those that similar almost to oxidation reduction or hydrolysis. Example of lysase is what we call aldolase. No? Aldolase cleaves the carbon molecule fructose 6 phosphate to two carbon compounds. Okay? The fifth classification classification of enzyme is what we call isomerases. Para saan naman si isomerases? Convert isomer to another. No? Converts isomer to another. Remember that isomerase is one of the important class of biochemical reactions involved in the conversion of isomer to another. Ano ba yung isomer? Pag sinabi natin isomer, they are structurally different, but they are the same in terms of composition, in terms of the number of elements present. Isomer, they have the same molecular formula, but they differ in structure. No? Example of the transformation that may include is the cis and trans isomerism. Okay? Example of which, to give you an example, an overview, yung glyceraldehyde 3-phosphate that will become diphosphate acetone phosphate, dihydroxy acetone phosphate. Okay? And lastly, we have your ligases. Remember that ligases is uh, capable of causing bond formation between two molecules to form a larger molecule. Again, when we said ligases, it is capable of uh, forming bonds between two molecules to form a larger molecule. So basically, these are the 6 classifications of enzyme. And the number the number besides it, no, the number besides it corresponds to its classification. Enzyme classification 1 should be oxidoreductase. 6 is ligases. Meaning to say, this corresponding number should not interchange. Why? Because we have what we call the EC code. Ano naman yung EC code? Ano ba yun yung sa loto? No? When we said EC code, that is the enzyme classification code. Okay? Instead of numbers, or rather, instead of name, or instead of uh, the word itself, we use numbers. And these numbers uh, represents the name of the enzyme. Okay? Our EC code is composed of 4 figures, 4 to 5 numbers, wherein the first digit represents the class. Okay? Whether as oxidoreductases, transferases, hydrolysases, lysases, isomerases, or ligases. The second and the third, or the second pertains to the subclass. And the third digit represents the subclass. And finally, the fourth digit represents specific number to enzyme. Basically, if you're going to put it in a layman's term or a simple way, a simple manner, EC code is just the same as your student number. Yun nga lang, each number represents or each number has its meaning. Okay? In our book, table 13-1, we have there the summary of enzymes or examples rather. Examples of enzymes, no? The class that pertains to number, first digit, oxidoreductases is 1, transferases is 2. Okay? So under oxidoreductases, we have lactate dehydrogenase, glucose 6-phosphate dehydrogenase, glutamate dehydrogenase. Common abbreviation LD or most commonly known as LDH. G6PD or G6PDH. Okay? Saan nanggaling yung DH? Dehydrogenase. Di ba? It's the former name. Okay? And this is the systematic name. The systematic name resembles or represents the IUPAC classification. And this is what I am telling a while ago. The EC code. The number that is specific for our enzyme. So example, we have 11127. This one pertains to oxidoreductase, one pertains to subclass of oxidoreductase, and the other one pertains to the subclass of the subclass of oxidoreductases. And the number 27 represents lactate dehydrogenase. To give you an overview, there are a lot of enzymes that can be found in the human body. Hindi lang din sa human body, meron pa rin sa yung mga enzymatic reactions. Diba? That's why we're just focusing on the clinically significant enzymes because if we are going to discuss the whole enzymology, baka fourth year na kayo, hindi pa tayo tapos dito. Okay? Lalo na kung aralin pa rin natin yung mga sequencing ng amino acids. Okay? So this one, transferases is Cas2, right? And if you notice here, all the EC codes starts with number 2, which means that is a transferases. No? 1 is oxidoreductase, 2 is transferases, 3 is hydrolyses, 4 is lysase, 5 is isomerases, and 6 is we have your 6? We have your ligases. Okay? So I will not include everything here, just have to browse your book and have the copy there. Now, how about for enzyme kinetics? Okay? Remember guys that enzyme requires our substrate. And in order for our enzymes to react with its substrate, it also requires activation energy. And when we said activation energy, that's basically the energy required. No? The energy required to raise all molecules in 1 mole of a compound. No? Enzyme catalyzes reaction by lowering the activation energy, as you can see in the graph. Now take note, no? The one way to provide more energy for the reaction is to increase the temperature. That's why temperature is important in enzymatic reactions. Okay? This graph represents the energy versus progression of the reaction, indicating the energy barrier. Okay? Remember, the enzyme considerably reduces the free energy needed to activate reactions. Okay? As what I've said a while ago, enzyme reacts biochemically in the presence of substrate. As you can see in this GIF, now this yellow illustration represents our enzyme. And this blue shape triangle represents the substrate, wherein the substrate reacts into the active site of our enzyme. If we are going to uh, represent or write the equation, it is basically E plus S will give you ES plus, wait, hindi plus. Pangit ng sulat ko ngayon. Nanibago ako. Okay. So again, like what I'm saying, if we are going to describe the relationship, it's basically E, which stands for enzyme, plus S stands for substrate, will give us what we call ES, no? And this is what we call the enzyme substrate complex. And this will give you enzyme plus the P. P pertains to product. Ibig sabihin, this enzyme, this substrate is important because because the active site of the enzyme where the substrate will react is required. No? Remember that the ES complex, the ES complex is a physical binding of a substrate to the active site of the enzyme. There are a lot of substrates. There are a lot of enzymes widely distributed in the blood, widely distributed in the tissue. Di ba sabi natin kanina? But specific enzyme will only react to its specific substrate. If you still remember the lock and key theory, that's that's it. Yun na yun. No? Parang yung kamay mo at yung kamay ng jowa mo. Kung hindi sila fit sa isa't isa, walang reaction. Yung lock and key theory, that's almost similar to hormones. Okay? Remember, if there is no substrate, the active if the substrate will not fit on the active site of the enzyme, there will be no reaction. There will be no reaction. Please take note of that. Okay? Now, remember, kasi nga specific siya eh. Dapat doon lang siya. Yun lang yung akin. Akin lang yun. Hindi pwedeng sa'yo. Para may reaction kami, dapat kami lang yung mag-bind. That's why enzyme has specificity. Yung ibig sabihin, specific lang, sa kanya lang. Enzymes are absolute. They are specific only for one substrate. Pwedeng nandyan yung isang enzyme, mayroong substrate. They will try to fit to one another. They will try to bond. They will try to form a ES complex. But if this enzyme is not specific for that substrate, there will be no reaction. No? Remember, specific, one of the enzyme specificity is absolute. The enzyme combines with only one substrate. And this combination catalyzes by corresponding reaction. Enzymes are group specific. Ano ibig sabihin nun? It means that they combine with all substrates containing a particular chemical group, such as phosphate esters. Aside from that, enzyme specificity includes bond specificity. Kung meron siya nire-require na group, meron siyang nire-require na substrate, meron din siyang specific chemical bonds for its active site. And lastly, no, enzyme specificity includes stereoisometric. It means that the enzymes that predominate combine with only one optical isomer. Okay. Now, for more information, enzyme may bind one or more molecule of a substrate. This may occur in what we call cooperative fashion. Okay? Now, how about the factors that influences enzymatic reactions? As we said a while ago, substrate is important in our reaction. No? Substrate, no? The reaction of our enzyme depends on the rate of the substrate present. Okay? Kung may enzyme ka nga, wala namang substrate, walang reaction. That's basically the same thing with enzyme concentration. Kung wala kang enzyme at may substrate ka lang, walang mangyayari dyan. Remember, the rate at which enzymatic reaction proceeds, no, it can be a forward or reverse reaction. And one of the most important factors that influences the enzymatic reaction is no other than the substrate. Remember that the enzyme substrate complex is important so that there will be a reaction. Take note, no? Take note that enzymes, that what you call this, the substrate binds no to free enzyme at a low concentration. Mahalagang tandaan na yung substrate nagbabind sa enzyme with low concentration. Okay? We also have what we call the first order kinetics. Actually, we also have the zero order kinetics. Ano kaya yung pinagkaiba ng first order kinetics at saka ng zero order kinetics? Okay? So let's differentiate. What is the difference between this first order kinetics and zero order kinetics? Let me share to you my black screen. Para maintindihan natin, ano bang ibig sabihin ng enzyme concentration? Ano bang ibig sabihin ng substrate concentration? Kapag po sinabi nating zero order kinetics, let me just change my ink to white. Okay. So we have zero order kinetics. I hope that you're still listening. And we have the first, no, order kinetics. Ito importante ito sa substrate, isang explanation na lang, no, sa substrate concentration at saka sa enzyme concentration. Remember that Michaelis and Menten hypothesized the role of substrate concentration in the formation of what we call enzyme substrate complex. No? And according to their hypothesis, ano yung sabi doon? This is what I mentioned a while ago. Substrate binds specifically to free enzyme at a low concentration. Okay? With the amount of enzyme exceeding the amount of the substrate. The reaction rate steadily increases. And when we said first order kinetics, no, the reaction follows a first order kinetics because the reaction, pag sinabi natin first order kinetics, the reaction is based, no, not based, directly proportional. No? First order kinetics, the reaction follows a first order kinetics if it is directly proportional, if the reaction is directly proportional saan? Proportional to substrate concentration. Ito yung paliwanag doon sa libro. Summarize na lang natin. No? first order kinetics. The reaction is first order kinetics if the reaction is directly proportional to the substrate concentration. How about zero order kinetics? Ano naman yung meron doon? No? Zero order kinetics naman, kung ito ay directly proportional to the substrate concentration, edi yung zero is directly proportional naman saan? On the enzyme concentration. Take note, reaction is considered as a zero order kinetics if the reaction rate depends on enzyme concentration. Okay? Depends on enzyme concentration. Okay, that is the substrate concentration and the enzyme concentration. Yun na pa yung ibig sabihin nun. First order kinetics at saka yung ating zero order kinetics. Okay? So yan. Yung graph na yan, iyan lang po yung ating pinaliliwanag. Yan po yung ating sinasabi. And kagaya ng sinasabi natin, no? Michaelis-Menten hypothesized the relationship between the velocity and the substrate concentration. And that is represented by this graph, or V is equals to V max S over Km plus S, where Vmax stands for the maximum velocity, S stands for the substrate, Km, not kilometer, corresponds to Michaelis-Menten constant of enzyme or specific substrate. Another factor that contributes or influences the enzymatic reaction is pH. pH is required. pH is a optimum or a great factor, no, that influences our enzymatic reaction. Bakit? Ano yung sabi? Enzymes are proteins, right? Enzymes are proteins. They carry what? Molecular charges. And any change in the pH may cause denaturation of the enzymes. Take note that most of the physiologic chemical or physiologic enzymatic reaction takes place to pH 7.0 to 8.0. But there are other enzymes that requires a wide variety of pH range. That's why it is important in enzymatic reaction to control the pH, no, by means of appropriate or by the use of what we call buffer. Kasi pag sobrang taas naman ng hydrogen concentration, di bababa yung pH. Dapat we are in a neutral pH to alkaline pH. Aside from that, you also have the temperature. No? Take note, kapag tumaas ang temperature, tataas ang chemical reaction. Abay, pag tumaas ang chemical reaction, ibig sabihin, increase din ang movement ng chemicals, ng molecules. Okay? That's why, human physiologic temperature ng enzymes ay sa 37 degrees Celsius. Why? Because the rate of denaturation of our enzymes increases as the temperature increases. Usually, if the temperature reach 40 degrees Celsius to 50 degrees Celsius, there is a dramatical increase in the reaction of the enzymes. Kaya kung matatandaan nyo, maarte yung inyong urine strips. Bakit maarte yung urine strips? It should not be exposed to air. It should not be kept at refrigerator. Bakit hindi? Kasi may temperature requirement tayo. Hindi rin dapat sobrang taas ng temperature ng environment. Why? It may denature the proteins that is present in the enzymatic reaction. Okay, that's why laboratories are establishing specific pH range. No, temperature for enzymatic reactions. 25 degrees, 30 degrees, or 37 degrees Celsius. Okay? Aside from that, cofactors is important and factor or a factor that influences enzymatic reaction. Kanina sinabi natin, cofactors can be an activator or a uh, coenzyme. Diba? Cofactors, usually ito yung mga inorganic factors natin. At ano yung mga inorganic factors na yun? Usually metallic ions. You have magnesium, manganese, calcium, zinc, and potassium. We also have metallic non-ion or metallic metallic factors such as your bromine and chlorine. Okay? And the most important factor that influences our enzymatic reaction is the inhibitors. Ano ba yung meron dyan? Madali na intindihin, inhibitors. There is someone inhibiting the enzyme substrate complex. Okay? The enzymatic reaction does not occur because there is an inhibitor in the active site of the enzyme where the substrate should bind, where the substrate should attach. Basically, we have the four yan eh. No? Pero mas kilala sila sa tatlong types of inhibitors lang. We have competitive inhibitor, we have non-competitive inhibitors, and uncompetitive inhibitor. Lahat naman yan competitive. Lahat naman yan inhibitors. But how they differ to one another? When we say competitive inhibitor, this is basically, there is a physical barrier, there is a physical inhibitor banded in the active site of the enzyme. Ayan may EPAL. Instead, yung substrate specifically for this enzyme will bind to the active site so that this active site and the enzyme and the substrate rather will form the ES complex meron kang asungot na nandyan. Okay? It competes with the substrate for the active site. Inaagawan niya. Kinukuha niya, pinupuntahan niya yung hindi para sa kanya. Okay? Now, ano yung nangyayari? As the substrate concentration significantly higher than the concentration of inhibitor, nataas yung ating concentration ng substrate. Why? Walang reaction eh. Kasi itong inhibitor sa'yo nandun sa active site. Okay? And take note that the inhibition is reversible. Okay? Bakit reversible? Kasi yung substrate is more likely than inhibitor. Halos parehas. Kaya wala ng reaction. May nauna na. How about non-competitive inhibitors? When we said non-competitive inhibitors, this inhibitor binds an enzyme at a place other than the active site. Free nga yung active site, pero meron pang naka-attach sa ibang surface ng enzyme. Okay? However, ito naman yung maganda sa non-competitive inhibitor, it may be irreversible. Okay? If the inhibitor, I'm sorry, hindi pala maganda, ito yung pangit, I'm sorry, ito yung pangit, irreversible siya. No? If the inhibitor destroys the parts of the enzyme involved in the reaction. How about uncompetitive inhibitor? Yung uncompetitive inhibitor, hinahayaan niya mag-bind yung substrate sa enzyme, pero nandun naman siya sa surface ng ES complex. Okay? Ikaw, parang hinahayaan mo lang siya nandun, pero umi-epal ka, sumisingit ka, wala pa rin reaction. Okay? So this is what we call inhibitors. And substrate concentration, enzyme concentration, pH, temperature, cofactors, and inhibitors are the 6 factors that influences the reaction of our enzymes. Okay. So like what I've said, we're going to discuss the clinically significant enzymes. Why clinically significant lang? Because if we are going to discuss every enzymes, all enzymes, we cannot discuss all. Hindi po natin siya kayang tapusin. And to start with, let's start it with the summary of the clinically significant enzymes. You have there, you have here, you have it. I'm sorry, you have this in your book. I just hope that you utilize your book. Okay, you have there the summary, no, the enzyme and the clinical significance of that enzyme. Example, we have your acid phosphatase, prostatic carcinoma. If you still remember in our clinical microscopy class, acid phosphatase is one of the enzymes that can be present in our semen because semen secretes, or is part of the semen, is the prostatic fluid where acid phosphatase reacts. From the word itself, acid requires acid environment, acidic environment. No, ang kapal niyan or ang kabaligtad naman yan is the alkaline phosphatase. Since acid phosphatase is predominant in semen, no, and because of the prostatic fluid produced by prostate gland, then increased activity of acid phosphatase is clinically significant in what we call prostatic carcinoma. ALT, aminotransferase, being a one of the more specific enzymes. More specific. Bakit? Konti lang, hindi siya ganun kadaming tissue ang affected sa kanya. Mainly liver. Kaya kapag mataas yung ALT mo, mataas yung mataas yung AST mo, mataas yung GGT mo, aba, ibang usapan na yon. Mataas ang ALP. Okay? Problemang liver na yan. Dapat mabuhay yun na yung diwa mo to protect your liver. Okay, amylase, breakdown, no, acute pancreatitis. Angiotensin, converting enzyme, blood pressure regulation. Anong ginagawa nito? Convert, no, from inactive form to active form. Paano niya kino-convert? Yun yung magandang tanong dun eh. Di ba? Ano na nako-convert? Pag conversion, ano ba yan? Ha? Pag conversion ng enzyme from one group to another, ano kayang klase yan? Uy, iniisip niya kung anong klase pag niya nagko-convert. Ha? Diba isomerase? Conversion eh. Okay? How about aspartate aminotransferase? AST. Si AST, ang sabi, non-specific enzyme that is increased in cases of myocardial infarction. Bakit non-specific? Pwede siya sa liver, pwede siya sa muscle. Kapag nag-injury ka or nag-crash injury ka, pwedeng tumaas ang AST mo. Okay? So we have creatinine kinase, tissue, muscle, heart, brain. Okay? Example, myocardial infarction, CKMB. Okay, and a lot more. I leave it to you to remember these enzymes. Now, like what I've said, we're going to discuss the clinically significant enzyme. And first things first is we have what we call creatinine kinase. Creatinine kinase is a more specific enzyme because it only have 3 isoenzymes, no? And mainly it is distributed in heart and skeletal tissues. Okay? Heart and skeletal tissues. Now take note that CK is associated with ATP regeneration in contractile or transport system. In fact, no, CK is involved in storage of high energy creatinine phosphate. Now, what are the sources of creatinine kinase? Skeletal muscle, heart muscle, brain tissue. If you're going to compare creatinine kinase to lactate dehydrogenase, more specific, ang creatinine kinase. Now, there are conditions wherein creatinine kinase is increased. What we call pronounced elevation. Kapag po sinabi natin pronounced elevation or marked increase, it means that there is a 5 or more than 5 times increase than the normal value. And 5 times or more increase in our creatinine kinase can be seen in Duchenne's muscular dystrophy, weakening of the muscle. Polymyelitis, dahil ba to, dermatomyositis, and most importantly, naka-bold pa nga myocardial infarction. Okay? Usually, ano yung problema? Usually, ano yung mga conditions na meron kang problema kapag creatinine kinase muscle? Severe exercise, trauma, surgical procedure, intramuscular injection will cause you trauma, will cause you injury in the tissue, will cause you injury in the muscle. Okay? Delirium tremens, alcoholic myopathy, myocardial infarction, moderate, ischemic injury, pulmonary infarction, pulmonary edema, hypothyroidism, and acute agitated psychosis. Those are the conditions wherein CK is increased. Now, ano yung sinasabi natin kanina? Merong tatlo siyang isoenzymes. No? Merong tatlong isoenzymes ng creatinine kinase. CKMM, CKMB, and CKBB. Kapag sinabi nating CKMM, that is heart and skeletal. No? CKMM, heart and skeletal. Kaya nga unang-una, myocardial infarction, CKMM. Pero pinakamahalaga diyan, tandaan natin yung CKMB. Or kaya, pwede mong sabihin na yung CK, yung creatinine kinase in cases of myocardial infarction is increased yung total CK natin. Bakit hindi mag-increase ang total CK? Two of its isomers is increased in cases of heart problem, myocardial infarction. CKMB is more on heart and skeletal. Almost similar sila ni CKMM. And CKBB, buti pa yung CK may BB. CKBB is brain, bladder, lung, prostate, uterus, colon, stomach, thyroid. Okay? These are the conditions wherein your CKMM, CKMB, and CKBB is increased. Now, like what I've said, one of the most important clinical application or clinical significance of our creatinine kinase is no other than its involvement in cardiac function, its involvement as our cardiac markers. If you still remember my question in our orientation, I have there a question pertains to the best protein cardiac marker, and that best protein cardiac marker is no other than our myoglobin. But if the question is the best enzyme marker, you have no doubt but to answer it as CKMB. AST and LDH is also affected or is also increased in cases of heart problem, in cases of acute myocardial infarction or myocardial infarction. But interestingly, it is important to note that CKMB is the first enzyme that will increase in cases of acute myocardial infarction because the onset of it is 4 to 8 hours. Di ba mas una siya? At mas una naman si AST kaysa kay LDH. Kaya yung tanong natin kay AST, the non-specific enzyme that will the non-specific enzyme that will increase first in cases of acute myocardial infarction, AST, Aspartate Aminotransferase. It will onset 8 to 12 hours. LDH sa yung pinakamatagal tumaas. 72 hours nga yung peak eh. Aside from that, 12 to 24 hours pa lang siya mag-onset after the arrest. Pero si lactate dehydrogenase naman, yung mayroong pinakamatagal na elevation days. 10 days siyang mataas in cases of acute myocardial infarction. Okay? Lalong-lalo na if we have what we call the flip pattern in lactate dehydrogenase. When we said the flip pattern, kasi the concentration of our lactate dehydrogenase, yung pinakamataas na isoenzyme ng lactate dehydrogenase is yung LDA2. LD2, 1, followed by 3, followed by 4, followed by 5. Ngayon, kapag mas mataas yung lactate dehydrogenase 1, teka lang, para maliwanag, yung serum LDH, kapag mas mataas ang LD1 kaysa sa LD2, this is what we call the flip pattern. And that flip pattern can be seen in myocardial infarction. Actually, not myocardial infarction only. There are a lot of conditions wherein flip pattern for lactate dehydrogenase is increased. No? Pero mas common yung flip pattern na yan sa myocardial infarction. Okay? So pag nagkameron tayo ng tawag doon, uh, electrophoretic pattern ng LDH, ang unang magpipik pag mayroon kang myocardial infarction is no other than LD1. Pero different siya pagdating kay CSF, di ba? Kung matatandaan mo yung CSF lactate dehydrogenase natin, mas mataas yung LD1 kaysa sa LD2 sa CSF. Pero sa serum, mas mataas si LD2. Pero pag mas mataas si LD1 kaysa kay LD2 serum, yun ay isang assumption that there is what we call flip pattern seen in cases of acute myocardial infarction. I hope I am clear. No? For assay enzyme activity, again, just to give you an overview, catalyzes both forward and reverse reaction involving phosphorylation of creatinine to ADP. But again, I will give a more detailed discussion about enzymatic activities or assays of enzymatic activity in our laboratory. We're going to discuss chunk by chunk, enzyme per enzyme, para hindi tayo malito. Okay? Usually, the most common source of error lang ng creatinine kinase measurement activity is hemolysis because it may increase or elevate creatinine activity. References shows that sample must be stored in a dark place if you're going to measure for creatinine kinase. It is because creatinine kinase is inactivated by light. And take note, please, of the reference range. There is a different reference range for male and female, as male is more yung muscle ability nila, no, yung using of muscle ng male is mas mataas kaysa sa female. Okay? And remember that the units for our enzyme is unit per liter. Next in line is we have the lactate dehydrogenase. This is what I am telling a while ago. Okay. The lactate dehydrogenase is a non-specific enzyme. Napaka non-specific yung enzyme na yan. Bakit? Tinatawag na siyang hematopoietic marker. Why? Because that is distributed in the RBC, in the erythrocytes. Okay? It is also distributed in the heart. Kaya nga pwede siyang marker for myocardial infarction. Aside from that, ano pa? Si lactate dehydrogenase din pwede sa muscle, skeletal muscle, kidney. Mamaya pag pinag-usapan natin yung mga isoenzymes ni lactate dehydrogenase, you will also recognize ano ba yung mga enzymes, no? Ano ba yung mga organs kung saan ang lactate dehydrogenase is involved. Okay? Kasi nga meron siyang 5 na isoenzymes. Kaya siya yung least specific. Dahil marami siyang isoenzymes, marami rin siyang organs kung saan siya pwedeng makita. Brain, erythrocytes, o yung brain, dagdag natin, brain, no? Heart, erythrocytes, kidney, muscle. At kada fraction ng ating LDH, meron siyang specific tissue. Okay? That's why lactate dehydrogenase is a useful marker for pernicious anemia, hemolytic disease orders, viral hepatitis. Bakit viral hepatitis? Liver. Bakit pernicious anemia, erythrocyte disorder? Because of erythrocyte. Myocardial infarction because of the heart. Pulmonary infarct, no, somehow in our what you call this? Embolism, pneumonia. Okay? Because of the lymphocyte activity. Skeletal muscle disorders, leukemia. Okay, source of error, any degree of hemolysis and instability of our temperature. Now, ano yung sinasabi mo, sir, na meron siyang 5 isoenzymes. LD1, LD2, LD3, LD4, LD5. Lactate Dehydrogenase. Pwedeng LD1, LD2, o LDH1, LDH2, LDH3, and so on and so forth. Okay? Si LD1, ano yung tissue origin niya? Heart, red cells. Kaya si LD1, kapag mataas, no? Kagaya ng sinabi ko sa inyo, mas mataas yung concentration kasi ng ating LDH, ng LD2 natin. This is 42 to 42 to 48% of the serum. This is 29 to 37%. This might be different, no, from our book. LD3 is 16 to 20%. LD4 is 2 to 4%. LD5 is 0.5 to 1.5. Wait lang. I forget to give you a mnemonic para sa first order kinetics at saka zero order kinetics. Buti na alala ko. Di ba sabi natin, zero order kinetics, and we have the first order kinetics. Okay? Ano nga ulit? Kapag sinabi po nating zero order kinetics, kapag sinabi nating zero order kinetics, depende po yun saan? Nakadepende sa ating enzyme. Tama. Nakadepende sa ating enzyme. No? Pasensya na ngayon ko lang ulit naalalang ibigay ang ating mnemonics. Enzyme, 0. Substrate, S. Sana nakatulong. No, hindi ko alam kung nakatulong sa inyo. Well, I hope so. Okay? So yung LD2 naman natin, heart, red cells din. Okay? So megaloblastic anemia, acute renal infarct, hemolyzed specimen. LD3, lungs, lymphocytes, spleen, pancreas. LD4, liver, LD5, muscle. So tandaan po natin ha, lungs, lymphocytes, spleen, pancreas. Hindi ko alam kung bakit pinatandaan to sa amin nung nagre-review ako. Tandaan nyo na lang din. Baka mayroong importante. Okay? At ano po yung mahalagang tandaan na yung LD3 natin is increased in cases of pulmonary embolism, pulmonary pneumonia, or in other words, kapag meron kang problema or meron kang tinatawag na pulmonary diseases. Okay? Pulmonary diseases. Okay? Now, what are the conditions kung saan pronounced, moderate, and slight elevated ang ating lactate dehydrogenase? So, pronounced megaloblastic anemia, widespread carcinomas, metastatic, hepatic metastasis. Ano bang ibig sabihin kapag sinabi nating metastasis? Kapag sinabi nating metastasis, yung cancer nag-spread na from other organ. No? Systemic shock or hypoxia, hepatitis, and renal infarction. Okay? Moderate elevation, myocardial infarction, pulmonary infarction, hemolytic conditions, leukemias, infectious mononucleosis, delirium tremens, vascular dystrophy. And most of liver diseases, mayroong slight elevation sa lactate dehydrogenase. Kaya hindi siya masyadong ginagamit eh. Slightly lang. Unlike AST and ALT. Nephrotic syndrome, hypothyroidism, and cholangitis. Okay? Next in line is we have our aspartate aminotransferase. And as you know, cardiac tissue, skeletal, and liver. Usually, ito tandaan nyo, kapag po slightly elevated ang ating AST and ating ALT, usually ano yung diagnosis? Pag slightly elevated lang ha. Kapag slightly elevated ang ating AST, the same thing with our AST, ano yung diagnosis ng doktor? If you said fatty liver, that is correct. No? Now, ano yung mga clinical conditions na associated ng ating aspartate aminotransferase hepatocellular disorders, which includes viral hepatitis and cirrhosis. Okay? So kaya sabi ko sa inyo, medyo babalikan natin yung liver function, yung mga diseases niya, in connection to enzymatic activity. Skeletal muscle, since skeletal muscle disorders such as muscular dystrophies and inflammatory condition. Pulmonary embolism is also considered. Okay? Enzymatic reaction or assay for enzymatic activity, Carmen method. Again, pag-usapan natin si Carmen at yung pang iba't ibang mga conditions or yung pang mga Oliver-Rosalki, Walker method, Tanzer-Gilgard method, no? Yan yung mga pag-uusapan natin sa laboratory. You also have your Problevsky-Ledoux, di ba? Ang gandang pangalan ng anak. Problevsky-Ledoux. No, pag nagalit ka, Ledoux. Ay, ayoko nang ituloy. Medyo pangit na. Now, source for error, hemolysis. That's why, yun walang problema, na-generalize minsan kapag enzymes, pag nang-hemolyze. Yung ibang enzymes, wala namang problema. No? Yung ibang enzymes, walang problema sa kanila kung sila ay hemolyze or hindi. Pero, mahalaga pa din na tandaan mo na most of the enzymes does not require or does not accept hemolyzed sample. Bakit hindi sila nag-accept ng hemolyzed sample? Eh kasi nga, it will cause interference in the activity of the enzyme. Okay? Range is 5 to 35. In some laboratories, the range is 0 to 50, 0 to 45. Okay? So these are the conditions for in aspartate aminotransferases is increase. Pronounced, moderate, and elevation. Kung mapapansin nyo, walang exact figure kasi iba-iba yung value. Okay? So kapag pronounced 5 times more than our normal value, acute hepatocellular, myocardial, no? Talagang sa myocardial laging lumalabas. Circulatory collapse. Ano yung circulatory collapse? Shock. Okay? Acute pancreatitis, infectious mononucleosis. For moderate elevation, we have biliary tract obstruction, cardiac arrhythmia, congestive heart. No? Congestive heart. Okay? So for slightly elevation, we have their cirrhosis and pulmonary infarction. Now, how about alanine transferase? Ito gusto ko tandaan nyo. Si alanine transferase, hindi siya specific sa liver. Marami ding organ na pwedeng mag-cause or mag-increase. Marami ding organ na pwedeng associated si alanine transferase. Pero mainly, lagi liver. Okay? Kaya nga kapag mataas ang ALT, ano yung sabi? Meron kang hepatic disorder. Okay? So ano yung mga conditions na yon? Ay bakit wala? Ano yung mga conditions na yon? Eh di hepatic disorder, cirrhosis, no? What you call this? Hepatitis, problem in the conjugation. Not necessarily problem in the conjugation pa eh, pero associated din. Usually, mataas ang ating liver enzymes kapag meron kang problem in the yung pag-intoxicate ng ating liver. Di ba yun yung ating function ng liver? Mataas ang ating enzymatic activity. Well, syempre, pag mayroon kang problema sa damage, meron kang damage. Bakit may damage? Mayroong problema. Ano yung problema? Okay, hindi nagko-convert yung ating liver. Okay? Next in line is we have our alkaline phosphatase. No? Alkaline phosphatase has the following sources: intestine, bone, liver, placenta, spleen, kidney. We also have what we call the regan. Ano yung regan? Pag Regan, ang origin ng alkaline phosphatase, ito yung mga carcinoma, cancer. No? Gusto ko po tandaan nyo that yung alkaline phosphatase na nanggaling or that originates in our bone is what we call heat labile. And the isoenzyme of our alkaline phosphatase that came from our placenta is what we call the heat stable. They can survive. No? Ano yung mga conditions na increase ang ating ALP? Biliary obstruction or hepatobiliary obstruction. Bone diseases, kasi nga, bone. No? Which includes Paget's disease, osteomalacia, rickets, hyperparathyroidism. Bakit ang hyperparathyroidism is involved in bone disease? Hyperparathyroidism is parathyroid hormone is important in calcium homeostasis. Ano ngayon, sir? Calcium homeostasis. Saan ba yun? Sa bone. Bone, no? Bone is the depository of our calcium in the body. Kaya nga yung ating calcium, as yung pag diniscuss natin to, yung ating calcium kapag nag-decrease sa systemic circulation, si bone ang nagre-replenish nun. Pero dapat yung calcium na nawala kay bone, kailangan mapalitan. Kasi kung hindi yan mapapalitan, that's the reason why kung bakit po nagiging brittle ang bones. Okay, again, the enzymatic activity will be discussed in laboratory. Source of error, hemolysis. Okay? Ano yung mga conditions na mataas ang alkaline phosphatase? Bile duct obstruction, biliary cirrhosis, osteitis deformans, osteogenic sarcoma, hyperparathyroidism. No? Ito mga to bone disease, liver disease. No? Parathyroidism associated sa hyperparathyroidism. I am not saying that yung problema dito yung parathyroid. No, nagiging associated, yeah, your problem here is your parathyroid. But nagiging associated siya doon sa bone because of the activity of parathyroid hormone in calcium homeostasis. Okay? Again, these are the source of enzymes no ng ating alkaline phosphatase. Again, si bone, siya yung heat labile. Pag sinabing heat labile, sensitive siya dyan. Si placenta yung heat stable natin. Okay? Inhibition by L-phenylalanine, 10%, 10% for bone, 75% for intestine, 80% for placenta. Now, kapag naman we have the electrophoresis and migration to the anode, ang unang mag-migrate towards the anode, no, yung mga isoenzymes ng liver, followed by bones, followed by placenta and regan, followed by intestine. Next in line is we have the acid phosphatase. Acid phosphatase naman, no, mostly prostate, bone, liver, spleen, kidney, erythrocytes, and platelets. That's why kapag there's a pronounced elevation of our prostate, of our acid phosphatase, siya ay associated saan? Sa ating prostatic carcinoma. Okay? Hyperplasia of the prostate, prostatic surgery. Osteoclast. Ano yung osteoclast? Ito gusto ko tandaan yun. Ito yung mnemonic ko nung ako'y magbo-board exam. Ano ba yung ibig sabihin ng osteoclast sa osteoblast? Ano yung pinagkaiba ng osteoclast sa osteoblast? Kapag sinabi na yung osteoclast, sisirain. Clast. Osteoblast, bubuuin. Okay, yun yung palatandaan natin doon. Yun yung palatandaan natin. Acid phosphatase is also increased in breast cancer. no? With bone metastasis. Ano ibig sabihin? Hindi naman talaga si breast cancer yung dahilan kung bakit tumataas ang ating acid phosphatase. Tumataas ang ating acid phosphatase in cases of breast cancer if the breast cancer, no, ay mayroong bone metastasis. Ibig sabihin, yung cancer cells within the breast cell o breast, nung nag-metastasize na, nagpunta na siya sa other organ sa bone. No? And acid phosphatase is also increased in our Gaucher's disease. Again, for our acid phosphatase and alkaline phosphatase enzymatic reaction, it will be discussed in laboratory. Pero the principle is basically the same thing. Ano lang yung pinagkaiba? Definitely, alkaline phosphatase requires an alkaline pH and acid phosphatase an acid pH. And it is important that the serum should be separated from the red cell as soon as possible, as clotted. Why? No? Para hindi magkameron ng interference. Kasi nga, erythrocyte is also a source of our acid phosphatase. Okay. Prostatic ACP is 0.02 3.5 ng per ml. Now, how about gamma glutamate transferase or gamma glutamate transferase? Brain, kidney, prostate, pancreas, liver. Pero sa lahat ng yan, no, sa lahat ng yan, pinaka-common siya saan? Sa liver. Kaya kayong pronounced elevation of our gamma glutamyl transferase is seen in excessive alcoholism. The cause of pronounced or marked elevation of our gamma glutamyl transferase is, ano yung cause? Bakit siya sobrang taas? Excessive alcoholism. Sir, tanda ko, sabi mo dun sa alcoholic cirrhosis. Bakit si alcoholic cirrhosis hindi siya yung cause? Hindi. Ano siya? Siya yung effect ng excessive alcoholism. Cause of pronounced elevation of gamma glutamyl transferase is your excessive alcoholism. And what is the effect of excessive alcoholism? Alcoholic cirrhosis. I hope it's clear. I hope it's clear. No? So this is our reference. Now, 66 to 55 international units or units per liter is for male and 5 to 38 for female. Ngayon, ano yung ginagawa kapag sobrang taas ng ating enzyme? Dahil nga, problem natin is detoxification, ano yung binibigay? Hindi makapag-detoxify ang ating liver. Ano yung binibigay? Nagbibigay ng Myra-E. So, tumawa ka. Bakit Myra-E? Ano ba si Myra-E? Antioxidant. With ano yung commercial ng Myra-E? Antioxidant kasi siya. It will help para ma-reduce ang mga free radicals that causes that interferes the detoxification process of our liver. Myra-E. With ginkgo biloba E. Something like that. No? That is an antioxidant. So kapag meron kang mataas yung GGT mo, tigil mo muna yung pag-inom mo ng alcohol. Tapos bibigyan ka ng doctor ng Myra-E kasi antioxidant. Amylase. Amylase is an enzyme, no? Amylase is an enzyme that is involved in the breakdown of carbon-oxygen bond, the starch. No? Ano yung sources ng amylase? Acinar cells of the pancreas and salivary glands. Mainly si pancreas. So, if that is involved, that is the source of pancreas, and this is anong problema natin dyan? Acute pancreatitis. Pero sino yung mas magandang marker between acute pancreatitis? Si lipase ba o si amylase? Mas maganda si lipase. Bakit? Because lipase originates primarily to uh, lipase originates primarily in the pancreas. Again, si amylase at si lipase, parehas silang marker for acute pancreatitis. But between amylase and lipase, mas magandang marker ng acute pancreatitis. Sino? Si lipase. Bakit? As lipase primarily originate from the pancreas. Pwede rin naman sa stomach. Pwede rin naman sa intestine. Pero since the problem is acute pancreatitis, then good marker for acute pancreatitis is lipase. Although, unang tataas si amylase. Okay? The enzymatic reaction or the activity of enzymatic reaction for amylase is divided into four approaches: amylocyte, sarcogenic, chromogenic, and continuous monitoring. So again, we're going to discuss that in laboratory. Lipase, like what I've said, for acute pancreatitis and primarily originates in the pancreas. Okay, how about our glucose 6-phosphate dehydrogenase and oxidoreductase 1.1.1.27? Tama? Pero huwag kayong mag-alala, I will not ask you to memorize the easy code. Ano naman problema nun? Nasa ulo mo nga yung easy code, hindi mo naman alam kung para saan. Walang kwenta yon. No, it's not for me to burden your life to remember. Pero minsan tinatanong kasi din sa board exam, pero nasa sayo na yun if you're going to memorize the easy code. But for me, I will not ask you to memorize that. But for you, if you want to memorize it, 1.1.1.27, actually hindi nga ata yun si glucose phosphate dehydrogenase eh. Si lactate dehydrogenase pala yung 1.1.1.27. I'm sorry. Okay? So para sa naman po si glucose 6-phosphate dehydrogenase? Okay? Ano yung ginagawa niya? For conversion. Di ba? For adding of hydrogen, oxidation reduction reaction. Okay? So saan siya mataas? G6PD deficiency. Okay? Which is an inherited sex-linked trait. Now, that is clinically manifested in drug-induced hemolytic anemia, myocardial infarction, and megaloblastic anemias. Okay? And our enzyme is also capable of metabolizing drug. Usually, yung mga cytochrome P450. Ano nila may metabolize yung enzymes? Paano nila metabolize yung drugs? By transforming these synobiotics into inactive so that it will become water-soluble so that our kidney will be able to excrete it. Di ba si liver ang nagawa niyan? Transformation, detoxification of synobiotics. Bakit kailangan gawin ng liver? Para ma-excrete ni kidney. Okay? There are a lot of drugs. Just have time to visit your book. No? And then take note that catalyze addition or removal of functional groups through hydroxylation, oxidation, dealkalination, dehydrogenation, reduction, deamination, and desulfuration is the phase 1 of the reaction of our liver, the phase 1 of reaction of our liver in metabolizing drugs through the help of our enzymes. And take note that the phase 1 of this reaction is often mediated by what we call cytochrome P450. And that is the end of our discussion. I hope you learn. I hope you understand. Thank you for watching.